Okay, ladies and gentlemen, this system looks horrible. My first step here has nothing to do with what am I going to eliminate. My first step is to say to myself, what's going to get rid of the fractions? So if I multiply the top equation by 6, which is the LCD, the fractions will disappear. If I multiply this bottom equation by 20, the 5 and the 4 and the 10 all divide into 20. Look at how much more decent this is. The top equation, when I multiply by 6, becomes 3x minus 2y equals 5. The bottom equation, when I multiply by 20, becomes 4x minus 5y equals 30. Now what we do is we completely forget that original system ever existed and just work with this system. Okay? Now, to eliminate the x's, I see there's a 3 and a 4. They both go into 12. I'm going to make one of them say positive 12 and one say negative 12. And it doesn't matter which. If I multiply the top equation by negative 4 and the bottom one by positive 3, I will accomplish that. So I get a negative 12x plus 8y equals negative 20 for the new top equation. I get 12x minus 15y equals 90 for my second equation. When I put them together by eliminating, by collecting like terms, I have a negative 7y equals 70. Divide by negative 7 and I get y is negative 10. What I now do is I plug back in. Now I'm not going back to the original equations. I'm going back to one of these two prettier ones because they're equivalent to what we started with anyhow. I'm going to go back to the 3x minus 2y equals 5 and I'm going to plug in a negative 10. Negative 2 times negative 10 is 20. 3x plus 20 is 5. 3x is negative 15 when I subtract 20. Divide by 3x is negative 5. My solution set is the ordered pair negative 5 comma negative 10. Again, it has that x format to it, so it is both consistent and independent. Now, went back too far. Okay, let's go to this next ugly system. I don't want to work with a system with decimals in it either. So my first goal is to multiply the top equation by 10 and the bottom equation by 10. Because I have a decimal, if I move those decimals over one place, everything will be whole numbers, integers. So I have 3x minus 5y equals negative 16. I have 5x minus 3y is a negative 16. Now is when I actually begin the problem. If I want to eliminate the x's, here's what I do. I see that one's a positive 3, one's a positive 5. They both go into 15. So I'm going to make one of the numbers negative 15 and one positive. When I multiply the top equation by negative 5 and I multiply the bottom equation by 3, it happens. The top equation becomes negative 15x plus 25y equals 80. The bottom equation becomes 15x minus 9y equals negative 48. When I collect like terms, i.e. I eliminate, not really collecting like terms, but when I add together, both sides of the equation to get an equivalent equation, I get 16y equals 32. When I divide by 16, y is 2. I take one of my pretty equations, not one of the ugly ones we started with, but I take one of my pretty equations, and I go back and I plug in a 2 for y. 3x minus 5 times 2 is negative 16. 3x minus 10 is negative 16. When I add 10, 3x is negative 6. When I divide by 3, x is negative 2. My ordered pair solution is negative 2 comma 2. Again, consistent and independent. All right, find two numbers whose sum is 13 and whose difference is 5. Now, you could do this problem by guessing, but a better way to do it would be to use what we've just learned about systems. Let's call one of the numbers x and the other number y. If the sum of two numbers is 13, x plus y equals 13. If the difference is 5, of course difference means subtraction, x minus y, the difference is 5 rather, it means to subtract, x minus y is 5. Now look at how nice this system is. It's a linear system. All we have to do when I combine is I end up noticing the y's eliminate. 2x is equal to 18 divided by 2x is 9. When I plug into the top equation, 9 plus y is 13. When I subtract 9y is 4. One of the numbers is 9 and one of the numbers is 4. How does that make sense? Well, if you added them you would get 13, and if you subtracted them you would get 5. So it's pretty easy. Kind of fun. Okay. The perimeter of a rectangle is 42 feet. The length is 7 feet more than the width. Find the dimensions. Now, on course compass, you're going to be asked to solve this problem by using a linear system. So we have to figure out a way to set it up. Okay. Remember, perimeter is always twice the length plus twice the width. So since perimeter is 42, 2L plus 2W equals 42. The length is 7 feet more than the width. That means L equals W plus 7. In other words, the width plus 7 gives me the length. Now, I have my system. Since L is alone, we're going to use substitution. So what I do is I go to the top equation and I replace L with W plus 7. I put W plus 7 in a bubble, i.e. safety nets. So I have 2 times what used to be L is now W plus 7, plus 2W equals 42. 2W plus 14 plus 2W is 42. 4W equals 28. W is 7. The length is 7, the width is 7, and to get the length, I plug back in. 7 plus 7 is 14. And it's again a good idea to always use, the correct dimension. So the correct answer, the width would be equal to 7 feet, and the length would be 14 feet. And we're done with sections 4.1 and 4.2.